at Fidel. We decided to write on machine learning and applications within the petroleum industry. We're going to start out with giving you guys a brief history of machine learning, kind of talk about what machine learning is, the main categories of machine learning, and then we'll go into specific applications. So we'll go ahead. Introduction: machine learning is a rapidly evolving form of computer science. The term was actually coined in 1959 by Arthur Samuel. It started out as a branch of artificial intelligence, and it kind of lost popularity to AI just because of like the inability to store like large sets of data. And it actually regained interest in the 1990s when it was more common to have like large data pools and more easy to store data. And it has widespread applications in many fields today, branching from the petroleum industry into healthcare and many other fields. A widespread accepted definition of machine learning is given by Tom Mitchell, an American computer scientist. It gets a little confusing, but basically the moral of the story is a computer with more experience, E, improves as, like if measured by P, it improves with more E. So it gets better at the task and the more experience it has. And in layman's terms, just the study and construction of algorithms to make predictions on a wide variety of data. This just kind of allows computers and machines to go against like strictly like static programs that are more commonly programmed in the computers. And then there's the 5 main categories of machine learning. It starts with supervised, has semi-supervised, unsupervised, active learning, and reinforced learning. I know this is like the 3rd or 4th time you guys have seen these, so we'll spare you the details on like the more in-depth conversation. But basically, each one has a set of algorithms, like number of algorithms that you can run, from k-means clustering, linear regression, multilinear regression, random forest, decision trees. And each one just kind of lets the learning program figure out the way to reduce the variety and create the most accurate prediction. And with that being said, we'll talk about the different applications within the petroleum industry. We'll start with Austin. Austin will talk about the geoscience side, and then we'll move to Fidel, who will cover drilling and completion applications, and then Derek will finish it out with production applications.
So, different applications in geoscience. We can classify different characteristics from the wells using spatial data from geologic information systems. And neural networks and support vector machines can work together in analyzing seismometer signals to predict phenomena like earthquakes, tsunamis, and landslides. And more specifically with petroleum, the algorithms can work together to identify different layers in the subsurface with the help of logs. Case study I did was done in the Norwegian continental shelf, and there are currently 6,000 wells drilled there, and 1,500 of them are exploratory wells. And with the exploratory wells, there's like very extensive data and GIS systems that they found. And for this specific one, they used 3 different machine learning models: a decision tree, the logistic regression, and the random forest decision trees. And for each one of those models, they used the 3 different sets of data. And as you can see, they kind of get increasingly more complicated, and the exploratory wells were mainly the ones with all of the data together. So the results for this case study, the logistic regression for all 3 of them was for all 3 sets of data was right around 70% accurate. And the decision tree was a little bit better, but as they added more data and used like the full set of data, it went down to about 60% and it got worse. But for this specific case study, the random forest model was by far the most accurate. And this diagram here is like a very basic decision tree model with the first set of data. But the random forest takes decision trees like this, and ones that are much more complicated, kind of puts them all together and runs it like from each one to the next one, and it goes on from there.
So I'm going to talk about drilling and completion. For the drilling, in the oil and gas industry, Directional drilling is a difficult task, but efficiency can be attained using artificial intelligence. The artificial intelligence is supposed to use previously available data to make decisions that lead to efficient side drilling. Additionally, machine learning helps in cutting costs and saving drilling time by allowing conduction of the post-analysis studies. Therefore, machine learning has come to improve the traditional rate of penetration prediction methods. Novilabs is one of the example companies that uses the machine learning in the oil and gas industry. The company connects engineering teams through a single data source and interactive predictive models that allows the asset teams to concentrate on improving the economic outcomes and capital intensive drilling programs. For completion, machine learning has been applied in hydraulic fracturing for the purpose of production enhancement from the shale reservoirs. For example, the US has some of the world's largest reserves in shale reservoirs, and it pumps a large number of treatments annually. One method of machine learning that applied in the closure is the ANN architecture. The diatomite reservoir that is found in Lost Hills is a classic example of machine learning applications and completion. The case study offers good examples of reservoir management because it has a unique nature and low permeability and has strong inhibition and weak rock strength. In the Lost Hill study, a new methodology using machine learning was introduced for infill well location selection. The approach led to identification of approximate 550 infill well candidate location, and the machine learning proved to be useful tool for operators as it allowed them to get closure data even from situations where it's difficult to get physical models. The method was not successful in Lost Hills because it's a very unique factor of the diatomite reservoirs.
And so tossing it over to production, there's definitely a lot of applications to use machine learning in production, and everything indeed like trickles down. So everything they talked about, the geoscience and the pre-planning and everything into the reservoir, clear into the drilling, and even to the completions, all of that trickles down into production. So a big part of the opportunities within production is, of course, production forecasting. Right? That's what we're trying to apply machine learning to the other parts, so that we can improve our production. So on the production forecasting side, we want to be able to better forecast not only our existing wells, but also our new wells. So the new wells coming online, it seems like they're always going to have different completions designs, right? They're changing them all the time. So being able to know how those designs are going to affect completions, or how that's going to affect the production, and also, again, being able to pull in the drilling and the geo data on that as well, so you have the actual reservoir data and applying that to better predict your new wells coming online, or your wedge wells. Also on the historic side, so your wells that already existed, that are already producing, being able to better predict downtime and frac hits and severity of frac hits and all of that type of downtime, and also even some shut-ins, so there's factors in all of that. And then so typically we have a production engineer who would assign a type curve to a well and then periodically do like a look back and check it, right, and then adjust it to make sure that it fits the best it can, and he would have to do that manually. And so that's a really good opportunity to apply machine learning, is to be able to automate that and to apply these regression models and everything to make that accurate. And also that helps when you're reporting to investors. Right? So in your investor relations, if you're under production, you get eaten up. It's bad for your stock. And a lot of companies have seen that. So it's very crucial that we get the production forecasting right on both new and existing wells. And also, so we can use supervised learning for that to better determine the well performance, and then unsupervised to perhaps group the wells to create type curves for areas, so better create type curves. Another opportunity here is liquid loading diagnostics. I'm not going to talk about this one too much because it was Haas's paper. It was the SP paper that he co-wrote. So we got to hear a little bit about that in class. But they used artificial neural network and k-means clustering, supervised and unsupervised, to be able to better predict when wells are going to load up. So that's crucial, especially in an area like we have here in gas wells and more of a gassy formation. That's not on like gas lift very often or pump jack. Also, on artificial lift, there's a lot of opportunity to better optimize those systems, and there's some SP papers that talked about rod lift and being able to sort through all the data on like dyno cards, and also being able to sort through false and malfunction, that kind of data, to be able to pull that out and to be able to allow the engineers to do better analysis on that. And then plunger lift is a huge opportunity there to better perfect your timing and your on and off triggers for the cycle of those wells, and also being able to, again, sort through false arrivals and all of that. And then perhaps even remotely make adjustments. You can tie that into it. And then also gas lift, being able to optimize the injection rate. That's something that's always kind of going to change your well declines. And of course, maybe that changes too with the price of gas, the cost of the gas that you're using to inject, and also your commodity pricing of your oil. Also, again, like that on compressor downtime as well. That's a big thing with gas lift. And also perhaps even knowing when to switch to a different form of artificial lift when you're actually injecting too much, that gas lift might not be the best option anymore. And so just a quick case study. This kind of wraps in, this is one of the best models I saw for production forecasting. And the big image just kind of shows, and it's blurry, but basically they pull a lot of data from all different sectors, the geology and geophysics and the reservoir modeling, the drilling completions, production, and even the infrastructure or the gathering system. So they pulled all of that, and then they studied all the data and then created a machine learning model to correlate normal and raw production data, and then calculate the relative importance and weight of attributes. And then they ended up determining that with 72 attributes, they got 97% correct. And then in the end, they calculated accuracy of well-to-well predictions and root mean square of 94% accurate, plus or minus 6%. So it's pretty good. So and what this is kind of showing is the more data points that you have, the more accurate the model can be. And that's kind of what it's showing down here, is the importance weights. And so that one, with the 72 attributes, it was the most accurate. So that's our presentation on machine learning.